Hi guys. So a lot of students actually messaged me and asked me, teacher, is it possible to do an inertia experiment using spring? Now, actually, you can find this in your textbook, page 19. All right. If you have your textbook with you, you can always take it out and we'll see it together. Okay, so here we got this Hashim guy. Okay, he did an experiment. Now, so guys, remember, don't presume that when you see a spring, it will always be the same experiment, because when you look at the experiment, you must always read through the procedure. Now, don't be too worried about memorizing the procedure. Why? Because guys, this experiment, you can't find the procedure in the textbook. So to be honest, there's no point in memorizing, because if it's not in the textbook, so it will depend on how you can explain already. So which means that if they give you the procedure, you just have to follow the procedure. Even if they want you to write the procedure, it will probably be one line only. So I'm not too worried. I wouldn't be too worried about that. Okay, now let's have a look here. So the relationship is between the mass of the slaughter weight and the period of oscillation. So biasanya, everybody will think that they will ask the blade, swing left and right, that one. Okay, but I don't think so. Why? Because that blade can be quite dangerous. If you don't capate it properly, the thing will fly out and you might hurt your friend, or you might fly and kill someone. So in this case, the smartest way to do is replace it with a spring. Maybe they'll give you a plasticine, then maybe they'll give you a retort stand. And what will happen here is you have to clamp this to the retort stand as well as a ruler. Now, you might be given a pin. So what do you need to do to this pin? Okay, so what you're going to do is that if you have a pin, so maybe you have to stick this pin or a needle or a toothpick to the plasticine to indicate the distance traveled by your plasticine. So what you have to do next here is, okay, follow the instructions. So what is your manipulated variable? It's definitely going to be the mass of the slaughter weight. But if it's plasticine, then plasticine. If it's slaughter weight, then mass of slaughter weight. So remember to write your M. Responding variable, period of oscillation, also remember to write your T. Okay, so what is the constant variable? Okay, because every single time when you do this experiment, what you are going to do is you want the spring to actually oscillate up and down this way. So you want it to bounce up and down. Don't go and shake the swing. Don't go and swing the spring unless the question really call you to swing the spring. Otherwise, I think that a spring should oscillate up and down. All right. Now, before you do your experiment, make sure you check your spring is in the elasticity limit. Meaning to say that sometimes, if your spring, maybe your friend, the sidang sebelum you, accidentally pull the spring too hard. So what will happen is that the spring will exceed what we call the elastic limit. Means to say that your spring is less bouncy. So before your experiment start, you should try and tarik and make sure that your spring is bouncy first. Okay, if your spring too keras means something is wrong with your spring, then you can request to change for a new spring. Okay, now, so the thing that you have to be constant, probably like a constant variable, is looking at how far you will push your spring before you let go. Because to start this thing, you have to tarik, right? Correct. So maybe it could be 5 cm, maybe it could be 7 cm, maybe it could be 8 cm. You follow what is the instruction in the procedure. All right. So the constant variable is the distance pulled by, or the displacement of the plasticine or slaughter weight, the initial displacement. So means how far you tarik, it will affect how much it bounces. Okay. So when we look at this thing, what are the trick questions here? Okay, so obviously you're gonna be asked to draw a graph. Okay, so maybe the graph will be a t square, s square, m, and then gram. All right. So one of the main things is that, okay, we usually draw something what we call a line of best fit. Correct. So you don't have to be too worried about your data accurate or not. The graph, if it's a t square against m, I repeat, if it's a t square against m, it will be a directly proportional line. So then your relationship will be t square is directly proportional to m. All right. Now, however, there are a few trick questions here. Maybe they want you to find, based on the graph, what will be, let's say, if the mass is 50 grams, how much is my T value? So what you have to be very careful here is, you see, okay, let's say if this is 50, so you will dot all the way up, And then after that, maybe you'll find like this, right? Correct. So let's say this is 10. Remember, your t is not 10 because your axis is t squared. So your t is actually square root of 10. Okay, of course, you have to press out the decimal places. Why? Because this is t squared, so you want to find t, you have to square root it. All right, so this is on the graph part. Okay, now what about your gradient? Do you have a gradient of the graph? Yes. So gradient got unit now, got, because gradient is y over x. So the unit will be s squared over g. So my unit will be s squared g minus 1. So make sure you take note on this thing. The unit for the gradient is calculated by using your y-axis divided by your x-axis, because this is in gram, so s squared g minus 1. So you can see here, they'll ask you, plot a graph, determine the gradient of the graph, show clearly, meaning to say that you have to draw your triangle to show that you have your coordinates and show your working. Usually, I will take the origin as one of the point. So this is my x, this is my y. And then after that, if the experiment is done on the moon, what will happen to the gradient of the graph? Now, because if you do this on the moon, what changes is gravity, okay? Gravity will not affect the mass, okay? Gravity will affect the weight. So since now we are doing mass of slaughtered weights, so the answer is there will be no change to the gradient of the graph. Why? Because gravity will not affect the mass. If it's weight, then it will affect. Mass will not affect. So my gradient of the graph will still be the same. Okay, Ken? All right. So therefore, these are the things that you have to be careful in your experiment. All right. Make sure you check your spring. Make sure you see your spring is bouncing up and down. Make sure that you take your gradient unit. Make sure when you calculate this, you remember to square root because of the t square and know what your constant variable is. And then if you all want to guess what should be the precaution that we should write, maybe you can drop a comment at the bottom. We can discuss at the comment section what should be a good precaution for this kind of experiment. So if you guys got no further questions, well, I will just stop here. I'll see you guys again for the revision paper 2. All right. Thank you, everyone, and good night.